Hello guys, welcome back to another problem solution video. Today we have yet another question here, and as always, let's first start off by reading the question. So student A, student B, and student C have been hired to help scientists develop a new flavor of juice. There are 4,200 samples to test, and each sample either contains blueberries or does not contain blueberries. Each student is asked to taste each sample and report whether or not they think it contains blueberries. Now, student A reports correctly on exactly 90% of the samples containing blueberry and reports correctly on 80% of the samples that do not contain blueberry. The results for all three students are shown below in this table. Now, student B reports 350 more samples as containing blueberry than student A. For some positive integer n, the total number of samples that the three students report as containing blueberry is equal to the multiple of 5 between 8,000 and 9,000. The sum of all such values of m is going to be our answer. Now let's first start off our first sort of variable here. So I'm going to say that number of blueberry samples, number of actual blueberry samples that the scientists have made, so number of blueberry is going to be equal to x, and we'll be using this later on. Now let's look at A, B, and C, which are just write as A semicolon, B semicolon, and C semicolon. Now for A, since we're doing this chart here, it has guessed that 90% of the correct samples contain blueberry. So this would mean that there's a total of 0.9 times x blueberries that student A thinks is going to be in the samples. However, we now have to look at the samples that student A guessed incorrect. Now, it guessed correctly that 80% of the samples that it got were not containing blueberries. This means that there were 12% that did contain blueberries that student A did guess. So this means that we need to add 0.12 multiplied by the total numbers of 4,200 minus x. Now it's going to be similarly to B and C, but just with different numbers. So for B, it's going to be 0.98x plus 0.14, 4,200 minus x, and for number C, it's going to be the same thing but with variable or with m. Now, we're going to look at our final paragraph here. We can see that B reports 315 more samples than A, which is what we use to solve for A. So, B is going to equal to A plus 15. So, no, not 15, 315. So, this means that 0.98x plus 0.14 times 4,200 minus x is going to be equal to 0.9x plus 0.12 times 4,200 minus x plus 315. I ran out of space here. And then after that, we just going to multiply by 100 to get rid of these pesky decimals. So it's going to be the same thing. And after that, we can move the x's from this side all the way to this side, and so to separate them out. And this is when we get 98x plus 14 times 4,200 minus x minus 90x minus 12 times 4,200 minus x is going to equal to 31,500. Now here we're going to expand all of these and then add together like terms to receive that 6x. So 6x plus 8,400 is going to equal to 31,500. So let's do a recap here. We sort of wrote out this equation. After that, we expanded with B and A with these that we've already been given, that we've already written out. After that, we moved all the terms that have x into them into one side, move the ones that don't onto the other side, and after that, we've expanded them to receive 6x plus 8,400 is going to be equal to 31,500. Now this means that 6x is going to equal to 23,100, which can further push out that x is going to equal to 3,850. And this means that altogether, A plus B plus C is going to be, well, just plugging in x and the x value into all the equations from before. So this is going to be equal to 0.9 times 3,850 plus 0.12 times 350 plus 0.98 times 3,850 plus 0.14 times 250 plus 2m divided by 100 times 3,850 plus 100 minus 4m times 100 divided by 100 times 350. Now, similar to before, we just need to expand it, and we receive 2,773 plus 49 plus 3,465 plus 42 plus 77m plus 350 minus 14m, which will then equal to 7,679 plus 63m. Now this means that, as I said before, in a condition where the total number has to be between 8,000 and 9,000 and be divisible by 5, we can see that 63m has to be bigger than 8,000 minus 7,679, and also has to be smaller than 9,000 minus the same number. This means that m has to be bigger than 5.09, and m has to be smaller than 20.9, around these numbers. Now, this means that m not only does 63m have to end with either 1 or 6, so which means that m has to end with 2 or 7, it also has to be within these conditions. This means that m has to be equal to 7, 12, or 17. For both of these conditions to be met, which is that the sum is going to be divisible by 5 and between 9,000 and 8,000. So our final answer should be 7 plus 12, plus 17, which is going to be equal to 36. Which means that the answer to this problem should be B. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.